Okay, so this is part of linear programming, and what happens, there's several parts to linear programming. This is actually the last step, so we'll start with the last step and add steps to the front of it. So when we're doing linear programming, we have what's called the objective function, and it's the thing that we're trying to either maximize or minimize. And then we get some what we call constraints. And so we graph that. The part that's enclosed is called the feasible region. And the only place that your objective function can have minimums or maximums is at the vertices. So what we do is we take each point, you want to kind of do it in a pattern so that you don't get confused about which ones you've already done. Okay, so there's my point. And now I take my objective function and I plug in, so remember this is x and this is y. So my objective function is 5x plus 6y. That's going to be 5 times 2 plus 6 times 10 equals 70. Plug in 7 and 5, so you get 5 times 7 plus 6 times 3, which is 75. I'm going to come out this way. For 8-3, we plug in 5 times 8 plus 6 times 3, so that's 18 and 40 is 58. And last one, 1, 2, so 5 times 1 plus 6 times 0. And we get 5. So we find the smallest value, 70, and it's this. We have 1, 2, 3, 4. 4 vertices, so we should have 4 vertices here. Okay, so we get 5 times 1 plus 6 times 2, so that's 12 plus 5 is 17. I'm going to go ahead and put it over here. Okay, so now I find the minimum. 75 looks like is the maximum. So the maximum occurs here at this point. And then I find the smallest value. Now if I were doing this in practice, I would choose, do I want my larger value or smaller value? Oh, whoops, that's equal to 58. So our minimum is 17. And so that is our objective function. Usually we know whether we're trying to minimize or maximum our objective function. Okay, so let's do it again with a new feasibility region. So we get 0.08, we get 0.00, 49, and 80. Whoops. So it's the opposite direction of the first point. Okay, so we plug into our objective function. We get 40 times 0 plus 5 times, or 50 times 8. That's equal to 400. Okay, we go on to the next one. We plug in. Oh, let's see. That's where that one goes. So 80, that's going to be 40 times 8 plus 50 times 0, and that is going to equal 320. 0, 0 is 0, and then we need to do 4/5. So 40 times 4 plus 50 times 5. So that is 1,660 plus 2,500. No, 250, sorry. So that's going to be 3,410. So, 410 is my maximum, and 0 is my minimum. Okay, so that's using the objective function. So the steps on front of it, or in front, are we need to find the vertices of the feasibility region. Then we need to actually like